Welcome to today's Energy Central PowerSession Generation Outage Excellence, streamlining processes and ensuring compliance in an era of energy transition.
Before we get started, we definitely want to give a huge thank you to the sponsor of today's event, Integ, for making it possible. And now I'd like to turn things over to our moderator, Mike Smith, to kick things off. Mike, welcome to the event. You have the floor.
All right. Thank you, PJ, and thanks everybody for joining us today. Welcome to today's power session. We've done a lot of prep for today. We've got some good stuff for you, so we are going to dive into it. You know, as you can see here, there's going to be a few introductory remarks that I'd like to make that will really just kind of set the table for what we're going to be diving into with today's panel. And then we're going to have a very robust panel discussion. And again, we encourage all of you to participate in this. If you put your questions into the chat, both PJ, who's our producer, and myself will be looking at those, and we'll be sure to incorporate those into the discussion as best as we can. So on that note, PJ, let's start looking at a few slides with some interesting data on it. This is some projections from the U.S. Energy and Information Administration. That's easy for me to say. I think we all know load growth is a big issue in utilities right now, and this just demonstrates that, yeah, it's not incremental growth. It's actually pretty big growth in terms of what the utility industry is used to historically. That begs a lot of questions around how we're going to generate all this power, and not only how we're going to generate it, but how we're going to manage these fleets of generation, be they traditional fossil, nuclear, renewable, etc. I think it's a new world we're stepping into, and we're learning as we go. But as that fuel mix, if you will, changes and evolves, I think it does add a layer of complexity to how utilities are planning outages of these generation facilities, and this is one of the things we'll be getting into. So you've got not only the growth challenge, but that changing mix and how you manage that. So I think that's a pretty interesting piece of what we'll be talking about today. On the next slide, this is just kind of a snapshot of how the power plant maintenance market is looking over time. Of course, it's growing because power needs are growing. Just one thing I'll call out as part of, again, that kind of that complexity piece that I mentioned earlier. If you look at the lower left-hand corner, where you're looking at it by equipment type or generation type, you'll see wind turbines down there. You know, I would venture to say not too long ago, that was a really small piece of what utilities were working on. I think that's going to continue to grow, and again, add more to, hey, how are we going to manage this in a planned outage environment? And then looking at the challenges of power plant outage and how you manage that. I'm not one to read slides, but I will pick out a couple here for you. And by the way, these slides can be made available to you if you just contact us here at Energy Central. I'll just call it a couple that I thought were particularly interesting. One is this operational complexity piece. I've mentioned that a couple of times already, and I think if you look at a large utility with these different generation fleets, that in itself is complicated. But when you start layering in some of the regulatory requirements, the distributed energy movement that's happening, plus with grid scale renewables and storage, I think it's kind of a recipe for complexity. And this is one of the things that we'll be talking about today. Another one that I'll call out just briefly here, and I hope we have an opportunity to dive into this in the discussion as well, is number 4 there that you see, the workforce changes. So obviously the workforce is changing as the older folks like myself are moving on to that next chapter in life, and the younger folks are coming in. The younger folks may be more tech savvy because they grew up with a computer in their pocket and in their hand the whole time that they've been alive, basically. So they're going to be more savvy and more receptive to some of the technologies that we're seeing, but they're probably not going to know as much about some of the processes inside of a power plant. And I think concepts like knowledge transfer and how you're going to get these folks trained up is a big issue. I know some of what I've seen over time is some really interesting examples of utilities using augmented or virtual reality in a training environment in these large power plants. So that's something else to keep an eye on. But we're going to dive into these topics now with our panel, and I'm going to introduce them one at a time. And in introducing each panelist, I'm going to ask them an opening question, and that's going to get us kind of diving into that panel discussion. So again, I'll remind you, please feel free to comment or ask questions in the chat, we will make sure we incorporate those into what we're doing. So our first panelist I'm going to introduce is Amit Patel. He is the Managing Director at Integ Consulting, helping power generators and IPPs to strengthen outage management, GADS reporting, and compliance workflows. He focuses on making reporting predictable by improving outage data quality. Boy, that's a big one. Reducing rework and aligning teams on defensible processes. Amit works with operations, compliance, and IT to streamline, capture, validate, and report, and he shares these practical lessons from real implementations across fleets. So Amit, thanks so much for joining us today. I am going to start off with a question about GADS, and for our audience, I think most of you know that is generating availability data system. It's a NERC compliance system, if you will. And we're going to start talking about that. And one of the things, as we were doing prep for today's session, that I found interesting is GADS includes both event data as well as performance data. So that's two different things that you're looking at. So can you share with us, Amit, where your utility customers and utilities that you work with are seeing the biggest challenges in staying compliant in their GADS reporting? And maybe the corollary to that is, why is this sometimes problematic? So again, what are those challenges, and then we can get into why that's been problematic, and maybe there's even a solution buried in there. So share with us your thoughts on that.
Sure. So yeah, I'm going to break this down into kind of renewables and non-renewables, right? Mm-hmm. With renewables, a lot of what you're seeing is that this compliance, reporting, all of this is very new. Not only that, the data, because of the nature of this versus, the traditional fossil and hydro units, it is very difficult to do this, because you could have let's say a solar plant with 100 inverters, right? You could have 150 turbines at these crazy large plants, right? So you're not just keeping track of, one turbine or whatever. Now you're keeping track of, hundreds of pieces. And in this reporting, you have to do all of this together. So it's automation, automation, automation. But even when you automate, the issue is that, in the fossil world, the folks that are doing this work, they've been around, like you said, for a long time. Like I said, like myself as well. But renewables are generally newer, and you don't have folks that are as skilled. So there's a kind of skills or learning gap in that folks aren't used to this. You don't have a ton of people that can actually teach this the way you have in the fossil world. So really the answer is, you have to do as much automation as possible. And in utilities, it's not as bad, because we're able to get into, for example, Pi and use the data. But when you get into folks that are smaller or cooperatives, they may not always have those, infrastructure to be able to easily share or allow folks to do the automation. So that ends up being a problem. The result of this is that, when we do a before and after, there's like full events that are missing. So if you're looking at compliance, it's just, it was getting done, but it wasn't getting done in a way that it was really compliant, right? So folks don't understand that, you can do it, but you can do it correctly or incorrectly. And often when we go in, we find lots and lots of problems. And luckily they're solved after. But a lot of folks that are doing this internally or with, whatever Excel or using files, they're often missing a lot of actual events that are critical to reliability that, NERC requires. Now on the fossil side, it's very easy to automate, but again, because of legacy, they just keep doing what they did. So we often see when folks switch over, you'll see that the automation is very easy to do, and it eliminates 80% of, rework, eliminates process, improves processes, and also ends up eliminating a ton of bad data and data quality, because we tend to do all of the validation work. So, that's the big difference, is that with solar, you can fully automate, but then it's a people issue. In fossil, it's more of a mentality that folks keep doing the same thing they've been doing. And then when we come in, it's like, oh my God, we could have done this all along. So, it's just simple things, automating your reserves, automating all of your generation. Often, plants are putting in the events, the same events that you put in the real-time system, right? Or the same events they put in elsewhere. So we're like, start with what you already have, and then you can make changes on top of that. It reduces error and makes sure that you're more synchronized with other systems.
Sure, and that was a great way to get us started, Amit. I had a couple of notes here. Let me ask you at least one of my questions. When you talk about automating the process, is this the data gathering, the actual reporting? Can you walk us through that just a little bit? I picture, a large power plant with all that instrumentation, which is generating data, of course. So once
Sure.
you get past that, and you referenced using pi in some of the fossil or traditional generating worlds. So just tell you a little bit more about what you mean by automating across that, if you will,
Sure.
that data life cycle.
So if you look at, for example, let's say solar and wind, right? We would be getting data from Pi at 5 or 10-minute intervals. And we use that to detect inverter or turbine level outages. And then we'll go further, look at the error codes. And so NERC now has this requirement to say, okay, you have to get to this threshold before you report. If we don't get to that threshold, we don't worry about it. But if you're getting close to that threshold, then what we do is we say, okay, I have all of this data and I'm going to put it together. Now I need what the cause of this outage is. So we'll go get that from the Pi or SCADA. And if they don't have it, then we have to ask the user to put it in. And we allow them to do it in the front end, and we alert them that we have to do this. And once they do that, then we actually create the NERC events based on all of their rules and algorithms, which get fairly complicated. And all of the other performance data we will get, we're getting this 5-minute data. I have a client where we're getting, I think last year we got over 1 billion pieces of data, right? Because they have 40 something solar and wind assets. So It's a lot of data, and you cannot do this manually if you're going to do it right. So we gather it. If there's manual intervention needed, we tell them. If not, we automate it. We show it on the screen to say, hey, this looks good. This is your performance data. This is your NERC events. And we have all the auditing behind it. And if NERC ever comes back, and you press a button to create the file, and then that gets sent to NERC. And if you want to do any reporting, you go ahead and you, again, pick what you want to report on. So it's fairly automated. We try to do everything as much as possible. And where they don't have the instrumentation or data, then we only, you could have 1,000 outages based on inverters, et cetera, in a month. But we make sure that if there's only 15 that are going to be critical to what NERC needs, we only allow them to work on those 15, if that makes sense.
Okay. Yeah, I'm starting to see what that looks like. Thank you for painting that picture. We're going to come back to you in a few minutes because I know you have some other good stuff to share with us. But we are going to introduce our second panelist, Aaron Westberg. Aaron has over 2 decades of energy and water experience spanning engineering, operations, and power generation across investor-owned utilities. At NextEra Energy, where she is today, she leads solar and storage project transitions from construction through operations and has successfully onboarded over 7 gigawatts of renewable infrastructure in 2025. Sounds like a heck of a lot of work and a lot of good stuff, Aaron. So thank you for joining us today. I do want to talk with you, at least initially here, and maybe primarily about what you're doing in that energy transition role and the kind of the heavy movement towards renewables that NextEra is kind of known for. And, I think in your role, you have a lot of experience here, and you're actually kind of on the front lines of the energy transition. So I'm going to ask you, how is this growth in renewable energy resources, how is that changing the shape of how a utility conducts planned outages and derates? So again, established paradigm, often for decades long in utilities. Now all of a sudden the renewable footprint is growing, and that's going to add some complexity. If nothing else, just new processes, maybe new skill sets, new people. But what does that look like in terms of maybe stepping back? How does that impact things? And then maybe a little bit more of a micro example.
Thanks so much, Mike. It's an honor to be here with you in Energy Central. Like Amit said, the transition of different energy sources really creates that extra complexity for the grid, for asset owners like NextEra and Florida Power and Light Company. I've been a part of both, and switching to renewables over the past 3-4 years has really been a great learning curve for a lot of folks. Wind has been a more established technology on the renewables space, and so I think it became that variable resource for us to learn from and then apply that to solar and storage, for example. So if you think about the way that outages and windows typically were seasonal or long windows like combined cycle and nuclear typically have their outages planned far in advance, the variable resources allow for much more short notice outages. Solar, for example, the sun goes down every night, so you do have an opportunity to do that short notice work. So that does allow for some, quicker triage work, unlike a nuclear refuel outage, which of course takes an army of people, a very calibrated work over a number of days. So it's just the nature of the work is a bit different. Like Amit said, right, you have hundreds of different inverters and, detailed collection systems. So even the assets themselves are very different than, one single point failure of one generator. Now you have all of these different assets throughout the field. But I'll say that as we, see these, I'd say the standards of reliability are the same, but now you have these distributed resources, as you mentioned, across different geographies and different use cases. That complexity that you mentioned earlier really does come to play. So I think that's one of the ways that we have evolved as an industry and as a company to think less long-term outage planning to continuously updating our outage prioritization model, and to even use some of that shape of the industry and the stack of the different resources to prioritize our own internal and industry outage models.
That's super helpful in terms of how we're starting to look at this. I did want to ask you a follow-up question as well. Amit talked a lot about automation of that whole data. I'm going to use the word data lifecycle, right? From getting the raw data at the generation point through where you're able to use it for things like reporting and managing maintenance processes. Does that resonate with you all in terms of what you're doing at NextEra? Like, is that pretty heavily automated, and are you all using Pi on the renewable side? What does that look like?
So the historians are mission critical. You're right, and automation is a bedrock of growing at scale and being successful to grow at scale like we've done. At the same time, you also have that data, the data source integrity, and then you have the growth. So we've automated some of those data flows by growing our OT-IT interface and also by upskilling our personnel. You mentioned that, before, and I really like the ability for all of us as consumers of these data sources to be validating them real time. So let's say, for example, you're the asset owner for a component like an inverter, right? You integrate with this controls team and you validate all of the signals for an event, whatever event that might be. Now, real time, milliseconds, right? You have all of this data, but then every report on a monthly basis, you have to go back in time and validate that. So then you build this machine learning into your process to make sure that your report is as accurate as you expect it to be. So whether that's at NextEra or anywhere else, we're all expected to have this instantaneously available, validated data. So I think that that's really taught us all to trust but verify our data, and that starts with the SCADA and the historian, but it really bleeds into our training programs and our warehouse of even drawings, our drawings accessible to people in the field so that they can access it when they're trying to validate like records for metering. aux power loads, for example. So it bleeds into that feedback loop to really make sure that not only is it automated, but it's validated and automated, right?
Okay, that's good. And you brought up a real Pandora's box we may want to open up later around the IT/OT interface. Always a challenge, organizationally, technologically, data-wise, et cetera. So we may want to come back to that, but thanks for helping provide some more insight on that. We are seeing some questions come in from the audience. We're going to get to those in a bit, but I did want to introduce our third panelist, Steve Turner. Steve is currently a consulting engineer with Sargent Lundy. He's overseeing the system protection for fossil generation department at APS, Arizona Public Service Company in Phoenix, for over 5 years. Steve previously worked as a consultant for a couple of years in San Diego and has held positions with Beckwith Electric Company, GEC Alstom, and SCL. Steve oversaw maintenance standards in the transmission department for protective relaying at Duke Energy in the Carolinas, where he developed the first patent for double-ended fault location on overhead high voltage transmission lines. He has a BSEE and an MSEE from Virginia Tech University, so I guess we should all say go Hokies. He is also an IEEE senior member and a member of the IEEE PSRC, holding the position of chairman for 2 different working groups. And we all know how important those IEEE working groups are. So Steve, welcome to today's session. Are you hearing us okay?
Sure.
Oh, good. Well, let me open up, just like I did with Amit and Aaron, let me open up with a question for you. And, you know, in our preparation for today's session, we've had several discussions, and in one of them, you brought up reactive maintenance, condition-based maintenance, and scheduled maintenance, 3 very different approaches, 3 very different needs and requirements. So when we talk about these, what can utilities be doing to improve their maintenance performance? And when I think performance, I'm thinking reliability and cost across these different maintenance practices. And maybe the background noise to that question is, do you see utilities moving towards more predictive or preventative maintenance as they work across these different maintenance practices? So let's hear what your thoughts are on what they can be doing to improve their performance across these different maintenance practices.
Right. Okay. So I do want to mention that before I came to work with Sargent Lundy, I was the chief protection engineer for Arizona Public Service, fossil generation, and they also threw in renewable energy sites in there, which was very interesting and eye-opening. And I was also a subject matter expert for the Palo Verde nuclear power plant. So anyway, you know, I've been involved in maintenance, I would say back since, you know, when I was at Duke, and I was involved in it, in asset management, you know, maintenance, and like I'm a relay guy. So, you know, you talked about predictive maintenance, and that's really, you know, I like to say distant early warning. So you have like devices that are taking measurements in real time, and they have some kind of algorithm that they're doing continuously. Maybe they create a database, or over time, you know, the distant early warning, you see something happen and you're like, well, this is when we should go out now and take a look at that piece of equipment as soon as we can get it offline and figure out what's going on. Is this a problem or not? It's like the 3 maintenance modes are run to failure, which is the worst. I know there was a utility in Florida that it was a small utility and they did that. It was horrible. And the reason why they did it was because the CEO was planning to sell the company. So all the money that would, you know, go into maintenance went into his pocket, which is, that guy should be in jail as far as I'm concerned for doing something like that. But anyway, anybody that does do that type of maintenance philosophy for electric utilities, they have rocks on their heads. But you know, the periodic, when I worked at, that's like for relaying, that's just typically what they do. But you know, one thing I was working on at Duke, but it was like is when you have these numerical relays, you know, they have the communication port, you know, you could just call them up and do the testing online. you know what I'm saying, and see like what are the measurements and stuff like that. And that would, that was something that I was starting to work on, but then I left, and then returning to the utility at Arizona Public Service, I was working on, being able to communicate with the relays that we were putting in the fleet. And before I came there, they had just been using one manufacturer that it had communication, but it was really limited. But I had, instead of using two of the same thing, I put in, we kept one of the existing ones and then put in a newer one that had a lot better communication. And that's something that I would have worked on. But one of the things that I did was I developed an algorithm where you can measure the capacitance from stator to ground. And the relay that we were using, there was a new relay that was recently has come out on the market, and it's just a really super powerful generator protection relay. But you could take measurements from that and create a database where you would calculate that capacitance and then just look at it over time. And if it changes, then you would know that there could be things such as contamination. And what was funny about that was when I developed that, there's many generators at APS, right? And that one particular site, the VTs are connected line to ground. Everywhere else, they're connected line to line. It's very common for VTs to be connected line to line for generator protection because it gets rid of some problems that you don't have to deal with. But because they were line to ground where we did that, it made it possible to do that algorithm, right? And so, but all the rest of them, we couldn't do it because they're line to line. So instead of being something that, we could go further with, it just wasn't possible because it was only one place we could do it. But anyway, I guess that kind of gives my, how I feel about, really, if you have the resources, then you can get involved yourself. It's not just something where you have to buy something canned from a manufacturer. You can do it yourself.
Steve, I had well, not surprisingly, I have some follow-ups for you on that. Mainly around one theme around utilities moving towards being more predictive in their maintenance practices. You mentioned the NERC database. You mentioned testing online. Do you see utilities changing some of their practices? Well, every 18 months we test this fleet of equipment, and every 6 months we test this fleet of equipment. Well, now we have all this data coming off because everything's censored and connected. To your point about testing online, are you seeing, hey, this one fleet we've been testing every 6 months for the last 20 years. We can probably get away with doing it every 18 months and use that time that we're saving to go over here where we're seeing more issues around equipment failures, et cetera. So are you seeing the use of this technology, and a lot of it, of course, is data driven, where utilities are changing those practices?
Well, what I like to say is, I talked about online testing where you don't have to have the relay techs drive out to the power plant or the substation. They get out, they wire it up, they hit and now everything, what they're doing is they're just doing automated tests, in the test set, and their computer's doing all the tests. Then when it's all done, they come through and they just scroll through, pass, 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 pass. As soon as they find a not pass, and they get on the phone and try to find somebody to help them figure out, why the relay failed the test. So, if you go to online, then, what can the relay tech say? They're basically just doing the same thing, but they're just doing it locally, where it could be done remotely. And if you were doing it online, then you could probably have, you could have it scheduled more often, right? If you could do it at the right times. So, that could be a real game changer for the industry.
Okay, so it's making the maintenance routines more productive and more efficient, although maybe not predictive.
Right. Yeah, like making the intervals between tests wider. I've never been like a big fan of that because somebody think, like that utility I talked about that was doing run to failure. They did that for like 5 years, man, and it's like the electric environment is just very rugged, and you can't afford to wait too long to get out there and see what's going on, what needs to be worked on.
Okay.
Mike,
all right.
if I can jump in for a second.
Go for it,
Two
Erin.
examples that come to mind, kind of replacing, I'll say, manual samples and having an online analyzer that really adds more data, are dissolved gas analyzers for transformers and particle monitoring in wind gearboxes. Those are two pieces of technology that give real-time upstream information about a potential failure, as opposed to going up tower or going out in the field and grabbing a sample. Like Steve, I'm an engineer, so I'm not in the business of less data per se, but but more data, and online data really tells you infinitely more than a sample, a grab sample. So I love the idea of online analyzers coming from the chemistry and the water world. So I love to hear that, the wind and transformers, have these technologies, and then you can utilize that data, and then you can really use that predictive monitoring to view way upstream. So those are two examples that come to mind that you're really now driving your maintenance programs much more proactively than you ever were able to with just, hey, every 6 months or every year, if you went to, and I saw a question in the chat about, weather constraints and delayed maintenance, and I mean, global pandemics, right? Like, heaven forbid you have something, right, that delays you, whereas that online analyzer gives you so much information. Now it's like, well, now I have to do something. I wasn't even prepared to do it, but I have to.
There's
so
that
it's
too.
telling me precisely. So there is an onus with that as well. Be careful what you ask for, right? But it's really infinitely useful. So I think that, again, the gearbox particle monitoring, and then dissolved gas analyzers for transformers, like I said.
Yeah, similar to what you're saying, I've done some work where we were looking at asset inspections across transmission infrastructure, hundreds of miles of transmission infrastructure. And, the project is finding stuff, rusted things and all that. And so they're like, hey, whoa, hold on. It would take us a long time to find these. You're putting a lot of work right on our desk right now that it's going to take us a while to get to. So it almost changes the culture as well as kind of the operating process of an organization that's charged with these things. So yeah, it's an interesting shift. I do want to kind of open up to the panel a couple of questions we've gotten in from the audience. So I'm going to ask the first one. And again, I'm asking this to the panel. I think you all have slightly different takes on some of these. So the first one is, how do the grid operators like PJM manage the outage information of renewables like solar and wind? And then it goes on, is the outage information listed with traditional generation outages? Is it aggregated? So, Erin, I'm going to maybe start with you on that, because that's a world that you live in. But I think Amit and Steve, you may have some thoughts on that as well.
Well, I live in the in a couple of different worlds. Like, my responsibility is to the wholesale customer as much as it is to, the NERC for compliance world. So, so I would say Erin is typically thinking about the asset proper and the contractual obligations for that wholesale agreement just as much as grid stability. But the, but your say-do ratio, whether your day-ahead agreements or your 15-minute ahead agreements are, to the grid are declared, like, you have to meet those, whether it's because the customer called for it or it's because, you're an investor-owned utility. That say-do ratio is still mission critical. So, kind of back to the question, it depends on how that asset is interconnected, right? And typically they have their own substation. So in my experience, they're discreetly monitored. Now there are scenarios where you have storage paired with solar or wind, and then that adds another layer of complexity. So that would be reported then through that same interconnection, but you still declare whether obviously you're generating or you're charging that storage asset, and the grid stability, voltage, frequency, all of those safety ratios are mission critical. So to answer the question, they know specifically what assets are on the grid, and they call on them per those protocols, like I mentioned, and the customers likewise. Now, in an unregulated market, it's a little bit different than someplace like Florida, where I have a whole entire fleet that I can orchestrate myself versus, a standalone asset that I'm operating basically on a single signal. So that's why I answer it a couple of different ways. But I think that answers the question, but I'm happy to hear what Amit has to say, because he really deals with a lot of diverse customers as well, and reports on their behalf.
Yeah, so I think when you look at PJM, right, you have to break this up into what's done in the real time, day ahead real time, which is, tomorrow, and what happens in real time, versus PJM using it for other purposes, right? Like the capacity market and capacity payments. So in day ahead in real time, yes, they're getting all of the outages for fossil as well as solar, wind, basically anything that's a resource they're going to want to know. And you also have what are called limits generally that you're sending. So this is what you're kind of estimating the resource is going to do, and part of that is because weather changes, right? So for fossil, the ambient is important, but for renewables, the wind and solar forecast is very important as well, because PJM or whoever, that's important, right? How much you can produce. In that world, everything is aggregated. But then when you look at reliability, ISOs are just starting to implement requirements for GADS, for solar and wind into GADS, because you have NERC where you have to report all these outages for GADS, but you also have PJM, New York, all these other ISOs where you have to report, but they are just starting to ask for this. And the reason that they're asking for this is not just grid reliability, but also what's a fair way to pay for people for capacity, right? Like if you look in PJM, and I don't remember, but on a typical fossil unit, if you have 100 megawatts, you're paid for that megawatts based and then take out your E40 factor, whatever, right? So let's say you're out 5% forced outages, you're getting paid for 95%. But for those solar and other resources, you're getting paid very little. I don't know the exact percentage, but it's going to be, a fraction of what you're getting for the other resources. So they're using this information to, figure out what those capacity payments should be, as well as for reliability. But then that's on after the fact basis, not real time basis. So it's not aggregated in the second part, which is the after the fact, but it is aggregated often in real-time systems, and systems that do limits in PJM. You have EDARD, and other ISOs you have systems such as CROW, and CAISO has a different name for it as well. So hope that helps.
Okay, yeah. As I sit here and Aaron, when you talk about having one foot, with your wholesale customers and the other foot in kind of the NERC FERC and the regulatory world, holy cow, it gets so complicated so fast. So there's a lot of good, smart people working on this. I'm going to continue with a couple more audience questions. And Steve, I'm going to jump to one that came in specifically for you.
Okay.
And this is something that I am not real familiar with, so you're going to take this and run with it. So it says, great comments, Steve. What do you think we need to do to raise the bar through commissioning IBR and IED?
Well,
So
I mean, you know, I was
that,
talking about using the newer relays to do that for IBRs. I mean, so this is just, I'm going to be honest, is like, my experience is, you know, IBRs is typically they're not spending as much money as you'd see at other substations. You know, the relays will have the communication capability, but you know, they may not be connected. So that means that the only way to get the information is for the technician to have to go on site. So, you know, if they want to really take advantage of the IED, then they need to be able to remotely call in. When I was at APS, it's like right before I left, they had built like a real flagship solar farm, and it had, you know, it was right, you know, I think the transmission voltage was 500 kV, and it was several megawatts, and it was a really nice control room, and I believe they could connect to all those remotely. But if you want to use the numerical relays, which are IEDs, then you have to be able to communicate with them remotely.
okay.
So that's, yeah, it's that easy. You know, that's a starting point, right?
Okay. All right. Well, yeah, that's your world, and you know it very well. So I'm glad that that question was asked and answered.
Yeah.
That one's above my pay grade. So
yeah, one thing I want to add, right, is that it also depends on the size, right? Because if you think a lot of these plants, they're a decent size, you're going to have people on site. But for a lot of these smaller sites, it's just everything's coming to the Renewable Operations Center. There's not many people on site. And if something happens, then somebody may be on call or they're sending somebody. So depending on the size, and depending on how well it's set up to give you the signals that you need, you may not have those. And when something happens, then a ticket has to be put in for a tech to go out and all of that. So you don't have that real-time feedback, or you don't have that feedback where, you know, someone at the plant is able to check something very easily and quickly. And as Steve said, the amount of money being spent is just way less, just, you know, just because of the economics of how this works. And often, yeah, older solar plants versus newer ones, like it could be night and day how some of this stuff is set up. And often there's plans to just say, you know what, we're not necessarily fixing all this if this is older. We're just going to replace it eventually. So that run to failure does come into play in some of these places, right? So
yeah. I mean, if it's a really big, you know, IBR, well, and then there's wind too, but just dealing with solar is, you know, if it's like several hundred megawatts, then definitely it's going to be worth it. You know, like some of these utilities, they have these little tiny places that just, they're a drop in the bucket, you know, and is it really worth it for them? Maybe not, but for when you have one that's several hundred megawatts, I think it's worth it.
Yep, yeah, size is a huge key.
all right. I'm going to go with one more audience question, and I think I'm going to get back to you, Amit, after this one, but I am curious, and I think all of you will have some thoughts on this one from the audience. The question is around some curiosity on the average of how many maintenance windows tend to be deferred due to a lack of available crews or extreme weather constraints. So, you know, in a perfect world, you plan your outage, you do it, right? But then Mr. Murphy shows up and there could be extreme weather events, or holy cow, that crew that was going to be replacing all of the pumps, you know, they got called off on this other emergency downstate or whatever. So are you seeing a lot of that? Which, again, I think the underlying theme to today's session is the complexity in managing all of this in today's environment. This is just another curve that gets thrown into the mix here. So what are you all seeing in terms of where those maintenance windows have to be deferred because of issues like that?
Well, I'm going to answer this first with safety first, right? We don't want our crews in the territory where the weather is so bad that it's not safe. And I'm thinking in terms of like a hurricane, right? If the sustained wind is over 35, 40 miles an hour, it's not even safe to be on the roads. And so, for example, right, like we want our customers to be back online as soon as possible. And we race between the wires and the generator teams to see who can get back online faster, right? Because we want to connect the wires to the online generators and get the customers back. But, you know, I think it comes down to knowing the resources are down and getting that triaged approach to getting the teams back to work, right, as safely and as soon as possible, and that the data drives that. The triage approach to the most important asset drives that as well. So, for example, I think this question is around like transmission or distribution lines, but it could be a wind turbine or anything else, right? I think that there's always going to be weather. I'm from Chicago in Iowa. That's the reason I live in Florida now. But, you know, so I can appreciate, right, that safety is first, but we still have to, you know, operate in these extreme conditions. And we want to make sure, like, we have dashboards and we have real-time monitoring for smoke in the area, for wildfire risks, and you know, in all of America, as well as storm trackers and wind speed monitors at all of our sites. And so we're always tracking what the risks are to our personnel and our assets, so that we can get back to work as soon as possible. Without, you know, giving you a number for this, I can say that we're always working really, really hard to get out there as soon as possible.
You know, as you were describing that, just a quick sidebar question. Your assets are probably all across the country then, right?
Yep, 44 states.
Okay.
And Canada.
Yeah. Boy. All right. So weather is definitely a big deal for you, and keeping an eye on that for sure, and all these different climate zones, et cetera. Anybody else want to comment on the challenges around managing those maintenance windows when you have things like crew issues or extreme weather issues? And if not, we can move on. You know, I'm going to kind of segue from that, and Amit, I'm going to ask you a question about outage planning, because that's kind of what we were talking about, and I want to just kind of extend that a little bit. So if you take a step back and you look at outage planning through a broader lens, what are some best practices you've seen when you work with your utility customers? Is it always a question of leveraging technology more effectively? Is it leveraging data more effectively and making sure you have that data quality? Or is it more about people and process in terms of how you can improve the efficiency and effectiveness of these practices? So
I think the biggest problem before you start, right? So you have technology, you have data, but then the biggest thing I see is that the processes are not efficient, because you get all these folks that are siloed into their groups, right? So everybody has their spreadsheets, everything is manual, everybody has their own sets of data, and they're not always talking, right? And often the technology helps people talk, because without it, they only need to talk at specific times, right? So the way I think of it is, most organizations, they're just following whatever was put in by the predecessor, right? So it's not always optimal. And for example, what I like to do is, okay, start with what do I need to fix and inspect, right? Steve talked about very low level, but then at higher level, right? You have hot gas path, you have this, you have that. If we're talking fossil, I need to know, right? Based on my last outage, based on run hours, based on, you know, mean time between failures, I could have other things, vibrations, all these things. What do I expect? When should I be doing the next inspection, right? And then once you have, so first of all, you have to agree on the data points and what you're going to do to arrive at that for all of your resources. But then once you have that, what do I do with it, right? How do I package all these things, especially if you have a bigger fleet, into what my outage plan is going to be? There are going to be approvals internally, right? Depending on different things going on. And how do I do all of those approvals? Because not only do I have my upcoming stuff, I have whatever the outages that are going on this year. And then you have validations because the ISO may not let you take outages certain times. You may not be able to do 2 units together. You have to make sure, you don't go below a specific percentage of your load with your capacities and everything. And you may also have to look month by month because ambience can affect certain things, right? And then on top of that, you have 3 to 5 year plans or 10-year plans that the ISOs are requiring. So you have to package all of that up and you have to get everybody to agree and make sure, because you can have issues if you don't agree with that. And then when you do all of this, if you're in an ISO, then you also have to send those outages to the ISO. So what is the workflow? Because often for this, you're not involving day ahead or any of those folks, but then the minute you're sending to the ISO, well, you got to get day ahead involved. So you got engineering, you got, asset management folks, now you got day ahead, and these are folks that are not always talking, but they need to be talking. And then once you plan it, you look at the milestones to say, hey, are we getting close? How are you tracking things high level, right? What's my actual versus estimate budget? I do a closeout. How well did I do? And this most important question, and I didn't understand it, but the most important thing for all of these is everybody wants to know what the maintenance windows are and how often they change, even if they're out further, because this impacts a lot of your longer term resource plans. It impacts, you forecasting how much output you're going to have at certain times. So everybody in the org is really, they're important. They want the outcome of that outage planning process, and they want to know any of the changes that happen as soon as they happen. So what I see in orgs is these are all 4 or 5 different things. And when they combine these with people and processes, definitely with the technology and data, we're able to take away 80% of the work, but it's really making sure that folks work together and it's not siloed and it's not like, hey, this is my process. If I do this, I'm going to lose control. Often that human element comes in as well.
Right. Good. And I'm going to want to come back to you on a few things that you said there about the process and determining next inspections and things. But while we're on this topic of kind of the maintenance planning and those processes, Steve, I want to come back to you. And one of the things we've talked about, again, in the prep leading up to today's session is that, most of these power plants are pretty heavily sensored, heavily instrumented. So there's a lot of monitoring, a lot of measurement going on. In your opinion, and from what you're seeing, what you work with, are utility leaders, these power generation leaders and their teams, are they leveraging this instrumentation as fully as they could and doing more with that data more effectively? And again, kind of this theme is how can they improve performance and maybe even those overall planned outage processes by leveraging some of the sensor and instrumentation data more actively, more aggressively, more holistically? Are you seeing that, and what does that look like?
I would just say, it really, there's so many utilities here in the U.S., so it really depends on each utility, what kind of culture they have, or sometimes it just comes down to a leader, that leader comes in and they're given the keys to the shop so that they can do stuff. And some people, they're just happy to just go with the status quo, which is kind of sad. I mean, it is sad actually, but so it just comes down to culture and the leaders in those roles, what they want to do. In a power plant, the generator itself, it already, a lot of times they already do come with a lot of monitoring equipment. Then transformers also, large transformers, they're going to have some monitoring equipment with them. So, and there are transformer monitors that are very powerful, and you can just get those. It's like you don't have to roll your own. There's stuff out there that you can just buy off the shelf, that'll do it for you. So I would just say the toolbox is there. It's just the people have to have the desire to want to do it. When I was doing it, I really like to, I was always, you're going to have to rely on other people, but it's like the more that you can do yourself, then you can tailor it exactly how you want it. Sometimes, there'll be vendors that they'll work with you. You know what I'm saying? So there's also that where they
Right.
will, you show them your vision or what you've been doing, and they'll work with you to help make it easier for you. So
Yeah.
there's all kinds of paths to success.
Yeah, it's in those vendors' best interest for their customers to be fully using those tools and getting all the benefits and promoting that. But one thing you said, I think was super interesting about the culture and the leadership aspect of this. I can remember earlier in my career, I've been in utilities for 36 years. When we were doing some work in the generation space, what was interesting was, utility has a fleet, generation fleet, and sometimes the culture and therefore everything that comes under that, the process, the practices, et cetera, that could be very different from not just from utility to utility, but within a utility from one power plant to the next. And that really speaks to your point about the culture and the leadership of how they want to run that, how they want to be more effective and more efficient, which ultimately affects reliability and cost. So yeah, it is an interesting dynamic. Thanks for that.
You're welcome.
Amit, we're going to come back to you. And I think you had some things you wanted to share with us. So I'm going to ask you about getting beyond compliance reporting, how utilities should think about overall performance and reliability. How does this matter? How are utilities approaching this today? And the big question is, where does AI fit into all of this? Because you can't go anywhere without hearing about AI, and some of it's great stuff. Some of it is a little bit of how's this adding value kind of a thing, and there's always the underlying data issues. But I think you have some good experiences you want to share with us, and maybe even
Sure.
walk us through something that you're working on.
Sure. So I think, piggybacking on what you asked, Steve, right? I'd probably say maybe 10% of utilities are using, a lot of the sensor data in the ways they should or they could. But if you go back to it, there's two aspects to it, right? The leadership, 100%, right? Without the leadership, nothing's going to happen. But then if you look at a typical org, right, to do this, you have to spin up a project, you have to get IT involved, you have to do this, and all of that costs money. And in many companies, they only have so much IT, so much folks to be able to do this, right? So this is where we're seeing AI come in, where, and I really want to be careful in that I don't trust AI. I use it because it is not reliable. So our motto and what we tell everybody is use AI to build a solution, to build a software. Because before, if you wanted to do something for something specific, you wanted to get a company or IT to build it, what could be $100,000? And that could be cost prohibitive, or it could be $50,000. Now with AI, we can take that whole process that took a month or 2 months, and we can collapse it into a week. We can have it write software that's safe, secure, and we can test it to make sure that it's predictable. And that's the most important. And then we can use that software. We're not going to use AI all the time because there's an aspect to it where it's not always going to be predictable. And in this industry, predictability is really, really important, right? So yeah, you are replacing what IT or vendors such as ourselves did, and you're doing it at a fraction of the cost. So now what does that mean, right? It's like your iPhone. Well, before you just used it as a phone. Now you can do hundreds of thousands of applications, right? Depending on what, and the cost of it is near zero. So AI is helping us get to that point. It's not perfect, but what I can tell you is we can probably do work at maybe with testing all of this at about a fifth of the cost to a tenth of the cost now. So it's huge. Where you could do 10 projects now, where you could do one, you can do 10, but then you have to have that leadership that understands it, right? And they have to understand technology. And really, unfortunately, it all boils down to that person in charge. If they're not gonna say, hey, we have folks that are not even starting to look at it, or we tell them, hey, there's no cost to this, start looking at this because this is going to come to a head sooner or later and you're going to be really behind. But it's just, they don't understand it or they can't grasp it because they've done what they've always done, right? So that's the biggest thing is I think folks don't realize the potential And they're throwing out the baby with the bathwater because, yes, it absolutely is not something that's 100% reliable, but that doesn't mean you can't use it to build a ton of reliable solutions by testing. Yeah, and the other thing that I do want to point out is that reliability and performance go hand in hand, right? If unreliable units are going to lose money, no doubt, right? And certain metrics or things you're doing just, when you're looking at it from the utility point of view, they're going to be a lot more conscious of what they're doing. Whereas if you get IPPs and whatnot, I mean, no matter what across the board, the compliance bar is way lower. It's more a focus on profit versus, just bar none across all clients. I've seen that. But then you see the converse on the utility side where there's not as much of they're so reliability focused, they're not as focused on the financials to say, hey, what are the costs, lost opportunity costs? And if you look at it, if you can understand and you look at mean time between failures, all of these things, you can actually reduce that. So it is going to help reliability. And in turn, it's going to help your profitability as well. But, it's very weird how, IPPs versus utilities, how they're treating reliability and financials. But yeah, so, again, the big key is, and I'll show you, we're doing in hours what we would do in months, right? Before with some of this stuff. So at this point, what I can do now, right? I can start just saying, hey, this is my data. I can select whatever data that I want, right? And I can start adding the data and I can just start asking questions. So here I ask, can you please get this data and perform graphical analysis on cost codes, okay? This interaction took a couple of minutes and it started giving me data, right? Now, if this data is something good, so it took 2 minutes, right? For somebody as a programmer or even internal to start doing this thing, it's going to be weeks. And it takes the business person telling them what they want. It takes a lot of effort, etc. So this, you're giving it a few prompts. You're telling it what you want. You're going to refine because it may not always read your mind. For example, when I do this, it uses cause code 0, which is a reserve shutdown, which often we don't care about. So you can, in our world, you can add knowledge and tell it you don't need this, and we have knowledge out of the box. But the tools that are there, it makes it very easy for an analyst to actually do a lot of this work without, somebody like Integ or somebody like IT. You just pick your data and you start talking to it, and it is producing tremendous amounts of information. And you can pick and choose and say, hey, I like this, right? And if you like this, then in our world, we just say, hey, go ahead and create a dashboard out of it. And you pick which things you want. And then if I go to my dashboard and I say, hey, this is my dashboard, well, I can go ahead and create it. I'm actually not connected, unfortunately, so I won't be able to show you that. Because when I connect, it's giving me, it's a little bit slower. But in the same vein, we can run a lot of these and do this within minutes. Somebody tests it, and it may take a day or two to test it and make sure it's doing what you want. But we're doing stuff that would have taken a month within minutes, hours, or days. So you can build a lot of this, and you can really improve everything you want to improve using AI if you do it properly. And our motto and mantra is that use AI to build these things, validate them, and then when you create these artifacts from AI, this is software. It runs the same way. So it's just like software you've tested before. It will run 100% reliably. You put in one set of inputs, it will always give you the same set of outputs, and that's all software is. So we've taken what would, cost a lot of money in the requirements and the building and really reduce that to near zero. All you have to do is put in what you want, test, and if you like it, you can operationalize it automatically and give access to whomever with all the data governance and all the good stuff and security that IT wants.
Okay. Okay, I had a question for you about that. And again, I said earlier, I'm kind of a data guy. So I look at this and I think, wow, especially when you talk about processes and that would take months or weeks, you're now doing in minutes. Talk a little bit about the data quality. When you walk into a client site, you know, are you making an assumption? Okay, your data quality has to be X, Y, and Z. How does that affect what we're seeing here?
So there's, and by the way, this, you know, this is a report that I had it, you know, a client asked for a report and we were able to create it on the fly while they were talking about it. Whereas in the old days, it would, not old days, even, you know, let's say.
Yeah, old days are not that, it's all relative.
Last year, it would take us talking to them, going back and forth, doing this, doing that. Now within minutes, you can just see it. And if I don't like this, I can pick 20 different variations and have it created, right? So it's just really a great way to collaboratively create these solutions and make sure. And if it doesn't work, if something fails, it's okay. The cost of failure is very little. And if it works, then the productivity and all those things are just amazing. So, okay. So as far as data quality, I need to break it up into two parts, right? Where you have operational systems, like we have GADS and other systems, those systems sift through and they have validations all within there. And what we do in our systems is it's a 4-step process, right? One is from the source, ingest or get the data. Number 2, we are going to run validations, right? So if there's and it's not just validations at the time, it's validations to say, is there a problem, right? And I'll give you an example. I actually have some of these. So give me 1 second. I'll show you. Even when you're in production, if you want to build, you know, alarms or any of these types of things, now you can build hundreds of alarms if you want based on, you know, what's going on, instead of you're limited because X, Y, and Z is happening, right? And you have to, each time you go in, you have to build for that condition, and that gets costly.
Okay. All right. Were you going to share again?
Yes. Are you able to see my screen or no?
I think we're looking at your screen, but we're not seeing the application.
Yeah. So often, you know, when you're doing this, like with solar units, you have, like I said, we processed 1 billion rows for one client last year, right? So, and some of them we have a monthly. You have no way to tell what's going on. So you need these types of things. For example, this is saying, hey, these 40 solar units are not receiving updates, right? So if you're using this data and you're processing it, users can't always go look for data and say, hey, is this good? Is this bad? You have to have a lot of upfront automation that checks the quality, that checks the inputs. And where possible, it can estimate it, but you have to alert. So then they can go back and say, hey, why did this, is it an instrument issue? Is this a PI issue? Is this an interface issue? Because you could have all these, you know, hundreds of thousands of data points. If you're not doing the data integrity, then, you know, garbage in is going to be garbage out.
Okay. Okay.
So, yeah.
Good stuff. All right. I'm going to jump back to a couple of things that we've touched on, and I'm keeping an eye on the clock because we're getting close to the end, but I did want to ask a question based on something Amit said, and I'm going to ask this of the panel. One of the things we've talked about is inspections and determining when to do the next inspection. And, you know, Steve talked about scheduled maintenance, condition-based maintenance, reactive maintenance. So I think this whole question around inspections and the different maintenance practices begs a little bit more of exploration, what we're doing here today, because it's so expensive and it's so labor intensive. Are you all seeing that a lot of this question around inspections and regularly scheduled maintenance, to what degree is this becoming more data driven as opposed to maybe a few years ago? In other words, are those inspection and maintenance decisions being made increasingly around what the data is telling you, and therefore maybe not getting too preventive or predictive maintenance? but maybe it's helping drive some of those inspection and maintenance decisions. Can you all just maybe share maybe an anecdote or what you're seeing in your organizations around the role of data in that inspection and maintenance scheduling space?
100%. We mentioned specific analyzers that drive individual asset responses, but another layer that we can add on is financial data. So if you operate like an IPP and an IOU together, that's thinking both about reliability and the financial implications of that, then you're really thinking holistically. So how can you understand the costs of that downtime? So it's easy to think three-dimensionally about. And I like the question that someone brought up in the chat, right? With winter weather and delayed maintenance. In this instance, I drive past, or I see a wind farm, and let's say a bunch of wind turbines are down for maintenance. There was some problem. How do I know which one to prioritize? It's just me and my buddy in a truck. How do I know which one to prioritize? Data should drive that decision. It should not be the one that's closest to my house or closest to the O&M building. It should be the one that's costing me the most amount of money, right? And the one that I have the parts to fix today, perhaps, right?
Let me toss that question over to Steve and Amit as well around an increasing reliance on data to make these inspection and maintenance decisions. What does that look like, Steve, in your world?
I mean, that we should definitely be making our decisions based on the data. Anything else is like, you don't want to do the guesswork, and it's easy to get that data. And there's all kinds of decisions that you can make, but it's like, you could decide, well, I'm using this, it's not like when you think about it, like for protection, you have a fleet of relays, right? That's how I think of it. And so this is something I've always noticed in protection is that, and it's really, really sad, and it is that people, especially fieldcraft, I hate this, well, I'll just be honest, is like, they get comfortable with something and they get in a zone of a comfort zone, and they don't want to be challenged or learn something new. Like when I, right towards the end of the APS, we went with, this newest relay, and there was like, yeah, they had to do it because I drove it, but you could see that they weren't thrilled about it so much, and one guy is like, sometimes there's people that will just do what's best for them, not what's best for the company, and that's really pathetic. So if you're in these kind of situations, then you can use it to justify, going to a newer technology and not letting some group of people or some person control, what's being used. And it's like, you buy something, you want to get your money's worth out of it, but at some point in time, it's time to move on, right? And it's like, so that's something else that's really important, is you can use this information to drive that. And that's something I did.
I was going to say that, and that again, not to beat a dead horse, but that brings up that whole culture and leadership thing again too, because I think maintenance practices tend to be very cyclical and people get very comfortable with that, to your point. And hey, the data's telling us we can do things differently, better, more efficiently, et cetera. So I think that is something that in some organizations is probably a bit of a challenge.
Right.
Yeah, for sure.
I mean, it can come from, it can come from anywhere, you just never know, but and then when you have the data, then it's like, you can really make your case. And it's like, whenever I worked in utility, it's like, I was going for what I thought was best, and having that data, people listen, you know what I'm saying? And it's like, so you want to get funding to do your projects, then having that data and saying, look, this is what we can do. And you can say that, we're spending this amount of money this year. We do this, and we'll be spending this much less next year. That really gets people to listen and get behind you. And like the people that are just a bump on a log, that's like, they can't fight that. You know what I'm saying? So the data is very powerful if you use it.
For sure.
The other thing I want to point out is that often we've tried to work with these utilities and say, hey, let's do benchmarking with your peers. Let's do this, let's do that. And it stops right in its tracks. And
right.
You can do it anonymously, et cetera. But really, if you think of it, right, in a lot of places, most of these, you're not competitors, right? You're in this area, you have your resources here, you have somebody on the West Coast. And if you can all improve the efficiency on your assets, then why not, right? Because it's just going to help. You're not going to need to build new assets. It's going to simplify in so many ways, but just that mentality, number one, is tough. Number two, when you get into using the data, well, what am I going to use? What can it help me predict? What can it help me diagnose, right? Certain things that no matter what, you're not going to be able to have the data because it's not there. Certain things can make a huge difference, but then you have to have engineers review it because it all boils down to the equipment, right? And how can you model it, and can you use this? Can you use that? But that engineering mindset is not there, or they don't have the luxury because they're doing 100 other things. And my approach is that if you can do the 80-20 rule and take like the 2, 3, 4 big ones and work on those, don't worry about the small things if you don't get to it. At least if you can do that, that's a huge improvement. But still, I think most utilities aren't there. It's just, there's too much other stuff that gets in the way.
Okay, good. Yeah, and with the investments that utilities are making in data systems, analytics, AI, and all the instrumentation and sensors that are providing all that data, you sure as heck need to be driving some new business value out of all that stuff. So yeah, these are good cases of that. Aaron, are you back? Let's maybe see. I'm not hearing you.
You tell me, am I back?
There we go.
Yes.
You're back.
Hey.
I did want to revisit one thing you said earlier that I mentioned, the IT/OT interface. I think that this is something that I just want to spend a minute on, because whenever I'm talking with folks in the telecom space, in the transmission, the distribution space, there is that legacy IT/OT disconnect. So again, that's a people thing, it's a process thing, as well as technology and data. Tell me a little bit, what were you referring to when you said that, making sure that you have that connection? And I kind of intuitively have a sense of that, but maybe for example, this is how it played out in your organization.
Yeah, I mean, I think for each system, it means something different to everyone, right? I was referring to, telecoms, just simple connectivity, right? Remote systems. A colleague called me and said, I want to grab a water sample, but I don't know if the customer's going to even have power out there, so what do I do? And I said, well, you might actually have to grab a sample and bring it inside. I don't like that answer either, but if there's no power, I mean, just because we have the technology doesn't mean that's the right answer. Whereas, right, for a brand new solar site, not having fiber, is a really costly data decision, right? You might have satellite backup or a cell phone backup for your data transmission, but that is not necessarily plan A. When you have fiber to the substation and you can utilize that for your operations team, now you have all of that data even more readily available, not just for the substation comms, but also for the maintenance technician who wants to work, like we just said, work on the right tasks at the right time and get, a nice site map and have the augmented reality access to the procedure.
You just started breaking up again, so I'm not sure what happened there, but we caught most of what you were saying. Oh, darn, still breaking up. Let me ask a question here to the panel.
All right, here we go.
There, we got you. You're back.
Just a cell phone. I don't know.
That's one way to do it.
I'm
yeah.
gonna use a tin can and a string.
There we go. Let me kind of ask this kind of closing question. We've covered a lot of ground today. And when we look at the energy landscape with all the things happening with the energy transition, the move to affordability, the growth in demand driven to a large degree by data centers and AI, that's a lot going on. So I'm going to ask you all to put on your utility CEO hat, or maybe you're the VP of generation. And what are some things you would do to make sure that you are staying in compliance, you're doing your reporting efficiently and effectively? And oh, by the way, doing this in a way that is still in concert, or to borrow a term from Aaron, in orchestration with being effective and efficient with these generating assets through and across these planned outage operations. So I'll ask you one at a time. Aaron, I'll go to you first. What are those one or two things maybe that you'd be doing to make sure, again, that you're doing the reporting, you're in compliance, but you're doing so in a way that it still is not impeding, in fact, maybe contributing to the effectiveness and efficiency of your generation operations?
Yeah, no, I love the question, because what we're talking about is a strategic function. It's not operations. It's not a reporting function. It's not a compliance. It's, we're talking strategically. So how do you do this strategically? I think that you have to invest in the systems that are helping you comply. So that's getting the right data, that's getting the right teams in place, whether that's, the software, the instrumentation, the skilled workforce that's engaged in the work that they're doing and they realize the importance. And then third is that workforce. So I think it's the strategy, it's the right systems in place, and then it's the workforce that really understands that you're investing in this. I mean, we call it rewire, but it's the reinvention of how you're doing business. You're not all in your lane. You're strategically empowering everyone to rethink how they're doing business. And that's smart alarms, that's new widgets, that's somebody hijacked my iPhone and was like, hey, I'm going to turn that into a vibration monitor. I'll give it back to you in a month. Like, it was really cool. I was like, okay. So I think, empowering people to think differently and giving them, the tools to, give you the data, show me the data that shows you made a difference.
Okay. Well, when I'm CEO of a utility, I'm going to hire you to be VP of generation. That was good stuff. Steve, how about you? What are some things that, Steve, you want to be looking at when you're in that leadership position and making sure that your groups are not only reporting and in compliance, but being as effective and efficient as possible for your customers, for your crew safety? What are some of those things that you want to do, and to Aaron's point, maybe strategically?
Yeah, what I'd say is, now as I'm a consultant and I'm working a lot with nuclear power plants, the focus is really just on the protection. But as a member of the IEEE Power System Relay Committee, I am the chairman of a working group that I actually, I formed it, and it's on condition monitoring of synchronous generators. So that, that's a report that we're writing, and it's going to come out in a year or so. And basically, that's how I can keep my skin in the game, is with this. And it's, some of the sections I wrote, are based on what I did when I was at Arizona Public Service. And there's other people there. We have vendors. We have other people from utilities. So I think that's going to be a really great paper, to tell people, look, this is what you can do. And it's like, you can do it, but it also, more importantly, is it gets the wheels turning for the right people. Then that's what it's all about. That's why those are reasons why we're doing it. And it, it like talks about, it shows, how that, what I did to measure the capacitance. It shows all the whole, it shows you how to do it. It's pretty cool, but there's all kinds of good stuff in there. So that's how I keep involved.
Okay. All right. Amit, I'm going to leave you with the last word on this. Again, you're the CEO or you're VP of generation. You've been having compliance issues, reporting issues, but you want to improve that, but still be effective and efficient and safe. What are those 2 or 3 things that are at the top of your list that you want to make sure your organization is doing?
So I think one of the main things is really you want to integrate all the processes and have workflow. Technology will help enable that, but you have to get buy-in from the people and processes, right? To work together to build an efficient process. And it's very easy with technology to do that. The second thing that I do this a lot, and it frustrates me so much, is that you have folks that are doing compliance, right? But then for an outage, you'll be entering the same information 3 times, 3 different people look at it. But there's no workflow to say, okay, this type of outage happened. Well, this could impact PRC4. Go look at this and go, put it with this person. So often the documentation is there and people do these processes, but you could cut the time by half or by 70%. You could reduce it if you just put all of this together. I'm a big proponent of also automated evidence collection, but when I go into utilities, they start doing it, but it's just so slow and so much of it is just manual work, which A, you're going to have lots of errors. B, you're still going to have to, rather than have a system do all of this and do with the workflow, you have to email this person, you're going to have to email that person, and it's all manual. So things take at least twice as long as they should. They're inefficient and they're prone to errors just because. And some of the compliance groups, depending on the org, they're the last to get to a lot of this technology. The technology they'll have often is just a software that tells them, hey, at this time, this is due, at this time, this is due, and this is my evidence. But there's nothing to say, hey, when this outage happens or this happens, go tell this person. Let them put in the information right away or combine these operator logs to find out what's going on. All of it is just so manual, unfortunately. So I would say look at it holistically, figure out the people and processes, and use the technology to automate, because the ROI is like instant. It's
right.
not a no-brainer, honestly. It's
yeah. And again, you're walking literally or figuratively into an organization that has these established practices for decades in some cases. So yeah, you got to figure out how to break that chain. But we are about at the end. I'm going to hand it back over to PJ, our producer, and I'm going to thank our panel and our audience. And PJ, take us away.
Thanks, Mike, and thanks, panel. Fantastic presentation. And special thanks, of course, to Integ for making today's event possible. For everyone tuning in, keep an eye out for a follow-up email with a link to the replay. And please give us your feedback so that we can incorporate that into future power sessions. We do take that seriously and love to hear what you thought of today's event. On behalf of the entire Energy Central team, thanks for spending a part of your day with us. We look forward to seeing you on an upcoming event. That concludes today's presentation. Have a great day, everyone.
great.